Instructions has a somewhat looser feel to it.
Yeah, it's got an almost improvisational tone.
Oh my gosh, how's everyone doing? Rick and Morty watching some Stat 201. Who's in the chat? Feel free to say hi. Got some good messages right there. What's up? Still need to set up jump. Are you on the Discord? If you ask people on the, I've been hopping on with Discord calls for like 2 to 5 minutes tops, and people have been getting it fixed. Are you on the Discord? If you are, like, I can hit like call, and like I call you, you share screen, and then boom. Jordan, are you on the Discord? The Discord is like the #1 way to get a hold of me and to message. I promise you, anyone who's met with me on Discord is like, boom. Skylar, good to see you. So I'm doing some homework and I was join up. Yeah, I just put the link for the Discord right there. If you could give me an example, which homework? Data analytics 2? We could do that right here. If you're doing data analytics, Elizabeth, good to see you there. So if you're doing data analytics 2, yes, okay, let's do data analytics 2 to start. And the Discord is so good to join up because all I have to do is hit call, and then I call you and boom, that's it. That's it. Got it. Can you go over chapter 3 homework, adults and presidents? Yeah, we can do that. We'll do that here next. Thank you so much. Here we'll do data analytics 2. And then let's do homework 3, MyPearson homework 3. Okay, yeah. So what I want to say is check out the visualization playlist if you haven't done this. Well, I need to put this at the start of it, like when we start this segment. So let's start the segment right here, and we've got things listed to do. Keep asking things for us to do. We're going to put them on the list and get them done. If you have to leave, it'll be in the list. So if you come in here ever and you're like, hey, can you do this? You can check back for the timestamps as I put them here in the video. And let's do some data analytics now, talking about how to do things. Okay, let's pin this message. Got jump open. And let's do it. Here we go to the main screen. Okay, so we're doing data analytics 2 right now. If you look over Canvas content, we do Canvas content on here. Let me put that on the list. Canvas content, gonna come up here soon. Check it out. So if you are doing the data analytics assignments, as I lag behind, we'll catch up. There we go, almost there. If you're doing the data analytics assignments, you are doing different data sets than I'm doing. I wanna make that clear, different data sets. This is the Pokemon data set because I like using it, and you won't be doing the exact same thing as me, but the techniques I'm doing, so Scholar, does this make sense? What I'm going to do here is what you're doing. It's just with different data. So, and if you're watching this in the future, the assignments could change. Let me point this out. When you are doing the data analytics assignments, to know how you'll be graded, always look to the what? To know how you'll be graded. I want someone to say it in the chat for points. Mubot's here giving out those points. He's over there on the side.
How will you be graded? Ryan must know.
The rubric. We got, that's where the 100 points. Let's start out strong here. You'll be graded by the rubric, 100 points right there. So look to the rubric for how it describes each thing. Even as I'm doing this right now, double check the rubric for each of the questions you're doing. Huge thing. Look at the rubric. Okay, so let's look at the very start of this. Once again, on your document, you need to have this information. Put this at the very top of your document. How do you find the mean, median, and that stuff in jump? We're going to show that right here. Good question, Joseph. We're going to do all this data analytics. We'll actually be covering this. Just watch this portion right here. When we get to a histogram, you will see the mean, median, mode, and all that good stuff in jump here in a second. So your name, your UTK email, your instructor name, your section, put this at the top. You look at the rubric. Literally has here information at the top. You get half a point for that. Next, you need to take a random sample. For this assignment, we are taking a random sample of 200 plus the last 2 of your UTID, which would be something like 223 if you have 23 as the last of your 2 of your UTID. So we go right here and we go to tables. And then under tables, we go to subset. Tables, subset, and then we type in 2, and then the last 2 are UTID. I'm going to pretend mine is 13. If yours isn't 13, don't use 13. Once you've done tables subset, click OK. This is your random subset you will use for your analysis. I'm using, once again, a different data set here, but make sure it says 213. Your graphics will also say that in some spots, so we can see if you took a random sample of 213. So now we have the random sample. The graders will know if you did that. We look at the next set of instructions. Create a bar chart. Now, question in the chat for some extra credit. Bar charts are a what display of what data. So look up here. So in the chat, practice right here. You should know this for the test. Bars and pies. You can make a pie chart of your favorite bars, a bar chart of your favorite pies. That keeps it linked in your mind, because if you ask someone your favorite bar or your favorite pie, what kind of question is that? And how many questions is it? I know I asked 2, but categorical, univariate, exactly. Pie charts and bar charts are univariate, categorical. Amazing work. It's so much good to see everyone here. Good practice. You just got to practice these things. Univariate display of categorical data. Joseph knows, even said it better for 50 points right there. So we're going to do a bar chart here to start, bar graph, what do you want to call it? Just remember, it's univariate categorical. Now yours is going to analyze color category, which is categorical. Notice how it says horizontal layout, include the values or percents above the bar, take a screenshot of the output and read the instructions and check the rubric in case I make an error here. Sometimes I make a little error, not big ones, hopefully. And so I'm using different data. So here's my Pokemon data. Tell me one variable I can make a bar chart of. One variable I can make a bar chart of. One variable in this I can make a bar chart of. Now you have to know how jump shows it. One variable I can make a bar chart of. All these are worth extra credit. Good guess. Speed, no. Skylar, good guess. We're throwing 50 points for wrong answers. Speed is not something we'd make a bar chart of. And that's because speed is quantitative. That's why I ask these questions. Skylar, don't worry, you're earning extra credit. Total. Where's total? I don't see total on here. Generation could. Is Jen on here? Where's generation? Generation, kind of. I wouldn't say generation so much. If you want to know, look for the ones that are red over here on the side. That indicates categorical and jump. This was a good question. More points in the chat. People know wrong answers are worth more than right answers sometimes, so you keep getting extra credit with those answers. But the red ones, name, yes, name. And that name, it's kind of an identifier-ish. Legendary, great one right there. Great answers, Catherine and Ren right there. I would say let's do type. I like type. Does that make sense? Like, it's categories. So this is categorical bar chart, analyze, and this is how to do it now. Analyze, distribution. And once again, if I'm going too quickly, you can always go to the visualization playlist where I go over this. I'm speaking specifically to this semester, but there's the visualization playlist in the chat if you're watching this, and that's more direct, is just showing you step by step. This is a conversation right now in this video. So now we go down here. We go to analyze distribution. Under Analyze Distribution, we simply double-click the Y columns, and that's all we need to analyze. Notice how it's red, meaning it's categorical in nature. So now we're going to just go ahead here and click OK. Once we click OK, we get the bar chart. This is a pretty big bar chart, not too big. We're going to put it in horizontal layout by clicking the top red arrow, which is where the options are at, and clicking Stack. Top red arrow, Stack. Now that you've got it stacked, I do like to stretch it out and make it look a little more pretty. And there we go. There we go. It looks a little bit better. Could screenshot this. Make sure to do Command-Shift-4 or snipping tool. You can also color your bar chart. These are the slightly optional things. This is optional, I should say. Nice light purple right there, light purple. But you have to put the percent or bars over it. I do suggest a frequency access. So here we are to the histogram options. We are going to put a count axis on top of it. There's the count axis showing us the counts of Pokemon in each type. And then next we go to histogram and we go to show counts. So there we go right there. We have the counts and we have a frequency table over here with a relative frequency. Relative frequency is the percent and the counts are the actual frequency. Now, looking at this right here, what do we see? What's the first thing that jumps out to you that we should talk about and mention numerically? What's the first thing that jumps out to you? What's the first thing that jumps out to you? And then I'll tell you how to like write it up and mention it. I think it says to put them in ascending or descending order. So very specifically, it says include a write-up of the different levels representing the data in ascending order. Now, ascending means to go up, to ascend a ladder. Descending means go down. So it does specifically say, and I want to point this out, to put them in ascending order. So this would be a rather long write-up where I say like water or flying is the least common category. You can actually turn this into a data table. Your table's not as big as this. Watch these steps. You won't need to do it for yours. Yours is smaller. And then I'm going to sort this right here by right-clicking and going to ascending order. So look at how the write-up, this would be a rather long write-up. We don't need the totals. You can mention that at the start. Maybe there's this many Pokemon in my subset. But then you would say flying was the least common with only one Pokemon representing only 4.69. And I don't want to say too much, but does that make sense what you need to write up here, Skylar? Is this one making sense for the write-up and for the graphic? The write-up needs to be, you need to write them up in ascending order. So this would be ascending. And then the graphic would include everything, including the frequency table and the bar chart. You can maybe make this more like that right there. That's pretty good. Yeah, awesome. So people should get great grades on this one. Make sure to be thorough. Make sure to have, I would throw the frequency axis on here, put your counts on. If it's probability to, that's fine. Make sure to do everything it says right here. So the next graphic, here, let's mark this. Let's say the bar graph. And let's mark this next one right here and talk thoroughly about it. I'll probably point people to this one if you'll come in, which is fine. I'll probably say, oh, you need to check out, like, we did it on Monday. Monday we did so much. Now we have a pie chart. What kind of display is a pie chart? So once again, hints right here. What kind of display is a pie chart? A pie chart. Kind of doing the same thing again, right? What kind of display is a pie chart? What kind of display is a pie chart? What kind of display is a pie chart? I'm reading the instructions, double check. Univariate categorical, Alexander, more points in the chat. So great job. Univariate categorical is pie charts. That's what they are. Great job, Ren and Elizabeth right there. So we need to write up the different levels in ascending order. So once again, when you get to the write up here, it's going to be very similar again. Have either the counts or percentages for each category in your write up. Let's go ahead and grab the pie chart way of doing it. So let's go here to graph and then graph builder. Graph, great job, Elizabeth. Graph, then graph builder. And have a note, if you have note cards, I always suggest taking these to say pie chart, univariate display of categorical data, meaning it displays one variable that is putting things into categories. Now here's the thing, we just did a categorical variable, so let's put type right here. You're just going to grab the red one it asks you to, make sure to follow your instructions, and drop it right here. You have different data than me. So now we click the pie button right here, and you get a pie chart. Now we are going to go here and go to label, label by percent of total values, and I think we're basically good now. Let's go ahead and hit done, and let's stretch it out so it kind of fits the screen a little bit here. I think you can go a palette. Let's see here. If I go to fill pattern, no, well, that's interesting. I've never done this. Ooh, that's weird. Undo that. I thought there was a way to like get a color palette, but it's not that big of a deal. I just like being extra. So, edit. No, there's ways. Legend setting. There we go. Color theme and divergent. I like that. There we go. So there's so many categories, whatever you choose to do. And that was done by right-clicking up here and going to legend settings. And then you can change the color theme. Jump has a lot of options. But yeah, you can do whatever you want. Here we go to this one right here. There we go. It's all right. It's hard to tell with so many categories, but you can see the bug and the water really well. It's just so many categories. The pie chart is probably not the best for this. If they were to take off for you doing this, let me know. And you can even edit these things right here. Now, what I want to say is this. When you take screenshots, take good screenshots. Take good screenshots. Your screenshot right here should look something like this. And we could even say, we can edit this and say type. Just type one, I don't want it. It doesn't have to be perfect, but you can edit so much in Jump by either double clicking or right clicking it. And I don't care for that extra type on the bottom, it's just redundant information. You don't have to have perfect screenshots, but I want you to look at this screenshot. Does this look like a somewhat professional pie chart you might see online? I'm not saying perfect, but does that look somewhat professional? If you think of this, I'm gonna bring it over to a Word document now. Take pride in your screenshots. Yes, you are describing the data you see in the charts, and make sure, I'm bringing up Word right here, make sure to mention the numbers, Skylar. Make sure to mention the values. So think about this. Here's my pie chart. Bring it up right here. I'm going to go here and click the picture and then add a little tiny border on it like this or something. Make it smaller-ish. Make it middle of the screen. There we go right there. Does that look like a somewhat... Actually, the border's taken up a little bit too much on it. I don't like the reflective border. It does weird things. Don't do that. Oh, I like that. There we go. I mean, does this look decently professional? Like a graphic you might see somewhere online. I know there's too many categories is a bit of an issue, but when you talk about this, you need to talk about the least common and most common. Yours is going to have a lot less than mine. Remember, flying was the least common. Since I did the same data, I could reference that table I made previously, and I would just need to go through and talk about it in ascending order again. And here's where I cheated, and you can just read through yours. Now I need to talk about flying was the least common, with only one observation, accounting for only 0.469% of the data. That's very low. So like there was only one Pokemon out of the 213 Pokemon. That makes sense, Skylar? Reference the numbers. Like, talk about the numbers, talk about the values, have good graphics that look nice, and be thorough in your explanations. Mention the values and be thorough and talk about the context of the data and what it means. That flying is a very uncommon type of Pokemon. So there we go. Now we are on to the histogram. So the histogram is different than these. Why? Why is a histogram different? Why is a histogram different? Why is a histogram different? Like what is different about a histogram? You have to think over here. You need to be like, why is a histogram different? What changes about a pie chart, bar chart to a histogram? What changes about that? What is different? Maybe some Girl Scout treats. I'll buy some Girl Scout cookies. Quantitative. Let's throw some points, Alexander, right there. Great job, Alexander. It's quantitative data. So histograms are univariate quantitative. Once again, I mean this. Get some note cards. Put it on your note cards. Histogram, display of univariate quantitative. And then try drawing a histogram. It really helps the more you see them. This is not a histogram because it has words on the bottom. Histograms do look like this. I've seen them called bar charts at times, but they are histograms because they're univariate quantitative, and the axis on the bottom will be quantitative. Let's go look at the instructions, and it says, create a histogram of the variable price. That's the variable you'll be using. Analyze distribution. The histogram must be in horizontal layout, have a count axis, take a screenshot of the histogram, quantiles, and summary statistics, and insert it into your Word document. Included a write-up about the histogram, describe the context to the reader, identify the shape of the histogram first, provide only the appropriate center and spread. Be sure to include the corresponding values for the center and spread, and then make sure to interpret these values properly. Yeah, sure. We added, make sure to submit your words. You roll a cruel late penalty. Other people be like, I submitted the wrong one. I forgot to hit the submit. It didn't show up right on the preview. So please check that out. Check it out. Okay, what can we make a histogram of here? Tell me a variable to make a histogram of. Just be like, just name it. Don't worry, easy question if we know it. A variable we can make a histogram of. What variable on the screen? 50 points, right or wrong? Variable we can make a histogram of. What can we make a histogram of? Once again, check out the visualization playlist pinned if you want. I go over this all, but this is where I get to quiz you. What can we make a histogram of here? Attack! 50 points, Alexander, right there. You're right, attack, 50 points. Because attack is quantitative, the attack rating of a Pokemon. Speed, great job. Elizabeth will throw some more points on there. Speed is quantitative, so we can make histograms of these variables, like to display and view it and see what's going on. And because histograms are very quantitative. Go to Analyze Distribution. Under Analyze Distribution, you can double click the variable or click the Y columns if you have it selected. Notice that it has this little blue triangle next to it. I don't know why they picked that for quantitative, but they did. And so with that, we're going to click OK. And whoa, this histogram, aside from a few whatses, is mostly what? I would say it's mostly this. I'm going to go mostly this. And I'm grabbing the little thing to, I click the top right arrow and click stack. I do that so quickly sometimes. You can click uniform scaling too. Click those buttons. Uniform scaling is, I just kicked my computer. Uniform scaling right there. But this is mostly what? And if the grader said no to this, I'd be like, I can figure out how much it is. Mostly what? There's 3 outliers. One of them has 190, so we can actually look at them. 3 outliers with an attack of 180, 185, and 190. And we can actually subset and see who they are. You don't have to do this, but this is the extra. Mewtwo, Heracross, and Rayquaza. Mega versions. Okay, so the megas are really popping off right there. But you don't have to do that, but you can highlight and go to table subset to see what the outliers are. Symmetric. So it's mostly symmetric, and there's a way to check that too. I'm going extra right now. I'm literally going like way in depth with this, but I like doing that. We click right here. We go to customize summary statistics, and we go to skew, and a skew of 0 is symmetric, and it has a tiny bit of what skew, probably due to the outliers. You can say a P word or R word. A tiny bit of what skew, probably due to the outliers. And if you see what side we're on, it's not a very big monster man, but a tiny bit of what skew maybe to this. We'll take a screenshot of it. A tiny bit of what skew. Tiny bit of what skew. Right skew, great job, Alexander. Right is positive skew, right to the high, left to the low. Don't draw this on yours. Right to the high, left to the low. Sure. And then right to the high, left to the low. And this means positive skew. This means negative skew. And the monster man, probably due to the outliers, a little bit of skew over there. You know, I would say this one is iffy-ish. So this is the positive right skew. If it's more symmetric, it'll have a 0 skew. Not super skewed, probably due to outliers. If the grader takes off, we usually give what that are pretty obvious. I half want to go look at yours. You know what? Let's do that right here real quick. Let me see if yours is obvious. You are doing price. I think I know which way that's going to go. I'm going to look at yours. Did Terry include the video too? Oh, that's dark mode. Yes, please check out dark mode. Thank you, Terry. Shout out to Terry right there. I made a dark mode video. Okay, analyze, distribution, price. I'll see it. Yeah, that's... don't say what the answer is, but is yours pretty obvious? I mean, don't say what the answer is, but is this obvious? I mean, like, some of them are iffy. Yeah. Oh, but double mine. That's pretty... Yeah, if you... Pretty obvious what that is. So your answers will be more obvious. Mine are more iffy. Because if it's skewed... And we forgot one thing, please, if you're watching so long, put histogram options, count access. It said to put a count access. I almost didn't do this because I'm so much wanting to analyze data. Histogram options, count access, make sure it looks like this. Just to be clear, your screenshot, you don't have to change the histogram color, but you can if you want. Light purple always. And go right here. And there is a magnificent screenshot of the histogram, summary statistics, and quantiles. So with this, is my answer is why did I care so much about skew? So Joseph and everyone in the chat, why was Brian so concerned about figuring out the skewness? So once again, we do a little bit of teaching here to understand the concepts better, and I teach towards the test. What's wrong with that, right? Teach and test you on later. Test you. Why am I so concerned about skewness? Why am I so concerned about skewness? Why am I so concerned? It determines, yes, it's part of shape, and it determines what? Okay, now I've color coded it. shape determines center and spread. So I've made a color-coded graphic right here where the pictures in black are the choices. And so when you do shape, you're really going to be talking about, is it more unimodal symmetric? And this is more of a symmetric unimodal. Unimodal is not the end of the world. It would also be fine pretty much if it had a shape that was more this, even sometimes kind of like that-ish. Then, I don't know, that one you want to probably mention as two modes and mention the centers of the two modes and maybe break it up and stack them. There's different things. But the ones we usually deal with are symmetric or skewed data. This is the easiest because it can just get more complex as you keep going. And so if you say it is skewed and outliers, you would only talk about the what? Say it in the chat. And so Alexander's based on the right track, more points right there. If you say it is skewed with outliers, you would only talk about, and I mean only, don't mention the other ones, only talk about the whats and whatses. So if you for shape say skewed and outliers, you will only talk about the what. And you will say the proper measure of this is this. The proper measure of center is what? Median and IQR, exactly. So let's just say I'm saying mine is skewed with outliers. Let's just say I'm trying that because it does have outliers. And here's what I would write up. I would write up my distribution is unimodal with a slight right skew indicated by the positive skew or just right skew. And there are three extreme outliers with a value of 180, 185, and 190 representing the attack power of Heracross Mega, Mewtwo Mega, and Rayquaza Mega. So those are the outliers. Due to the nature, see, everyone writes exactly what I write. Please don't write exactly what I write. Put in your own words. Just don't write word for word what I write. Like people start writing due to the nature. Then I'm like, just think like all we're saying is because of this. So we're saying because of this, or the shape has determined for me the center and spread, or now I know the proper center and spread. So think of your own words. Don't use exactly what I say. Don't just fill in a blank with what I say. Think about 10 different ways to say it. You ready? Go. Due to the nature of the skew, because it's skewed. I have decided because it's skewed. The skew nature has determined that we will use. The skewness of the graphic indicates we need to use. A proper center and spread because of the skew will be center and spread are determined by skew or normality. The data is very skewed, so we shouldn't use these, the proper measure of center. We can do a billion ways. There's so many ways to write this. So please don't do word for word what I say. I realize that as I'm going really slowly, I just see someone typing this, and now they've stopped. And so all we're saying is shape determines proper center and spread. That's all we're saying. That's what we're telling someone. And now we would say, I'm using the median. Now here's where people make mistakes. The median needs to be interpreted in what? All data needs what? Worth 100 points. All data needs what? Which I'm going to do right here for my data. All data needs what? As I interpret this value, you're going to hear the what of it. Context, Alexander, 100 points right there. Mary, if you speak up, you get those points. Make sure you hear all data needs context. We put that on the test so you won't get it wrong. So I would say something like the median represents the 50th percentile of attack powers, which is 75. 50% of Pokemon have an attack power higher than 75, and 50% of Pokemon have an attack power at or lower than 75. Technically at or higher than 75, like the median is, the middle one, so at or higher than the median is 50% of the data, at or lower than, and it's attack power representing attack power of Pokemon context. Now the IQR you can also cheat and get, but who can figure out for another 50 points what the IQR is on this data? And notice how when you look at this, the mean and standard deviation are over here on the right side. Really? I don't know how that even happened. Those are right there, and these two are right here. And it's 45. Amazing work, because remember, it's the IQR, the range of the middle 50% of the data. If you go from the 25th to the 75th percentile, you're just doing the range. It's literally the same idea of max minus min, but it only encompasses the 50% of the data. So if you want to think about it more theoretically, by using only the middle 50% of the data, you would be excluding what on the far sides of the data? What is over here on the far sides that would not be included in this calculation of range? What is generally on the extremes of the data, not on the low side for this one, but on the extremes, which is not in this calculation of range? Hence why we use it when there are these. Outliers, Marcus, great job. So if you're trying to remember, like theoretically, why would you use the IQR? The IQR is only the middle 50%, so it doesn't include the extremes, and it's a percentile measurement like the median, so it's paired with the median, and the median is not impacted by outliers either. That's why we use those. Last but not least, the mean is impacted by outliers because they're extreme values and you're averaging them. And then the standard deviation is found via the formula. We can actually, and we'll just end with this, then we're going to do the homework next. Stay tuned. And thank you so much, everyone. The mean formula is y bar, the mean of variable y, is equal to the sum of observations of y. Like if you add together every Pokemon's attack and then divide by the sample size, how many Pokemon you did. The standard deviation calculation, which we never have you do by hand, is going to be the distance an observation is from the mean. So you're using the mean in the calculation, divided by n minus 1. And we do that for samples to, long story, to if we have a small sample, it inflates the standard deviation due to uncertainty due to smaller samples. Now we take these differences and we square them and we sum them to get a sum of the squared differences. And then we square root it to make a standard deviation. I go into more detail in the lectures, but the thing I wanted to point out is that if you notice, the mean is used in the calculation of the standard deviation. So the sample mean is part of the calculation of standard deviation. So theoretically, it makes sense that the two are paired together, and things distances from the mean, i.e. outliers, would inflate standard deviation because they would be further away. And the distance an outlier is in the positive negative sense doesn't matter because you're going to square it. It doesn't matter. Knows all the answers. So Skylar, I hope that really helps out. This has been a longer segment on data analytics 2. I'll be directing people to this video here, but I hope this is a step-by-step. You now know what to say. Make sure to give context. The range of the middle 50% of the Pokemon's attack is 45, ranging from the 25th percentile of 55 attack power to the attack power of 100. What's up, Miles? Reading through the Discord. Feel a bit better. Awesome. I will meet. That's awesome. Miles, 100 points for everybody. Thank you, Miles. That makes my day to hear that. Miles, we're putting a little chill music on. Going to the next segment right here. That is awesome, Miles. Thank you so much. I'm glad to hear that. Discord rocks. So, and also, if anyone ever wants to meet with me, it's so much quicker to meet on Discord. So much quicker. It's like, I just hit call. Someone's like, can you meet? I'm like, yep. I'm like, are you free now? And they're like, what? And I'm like, are you free? And they're like, yeah. And I just go, beep. I'm like, hey, you want to share a screen? They're like, yep. We solve problems in like 3 minutes. It is. I used to be like, you schedule things on a Zoom with somebody, then you wait, they show up, and then they're like, Discord's a billion times faster. Like, it helps me out so much. So thank you everyone using Discord. I know like some people, it's like, I don't want to use this app. I don't know how to use it. How I felt for about a year. Being serious. I only got the hang of it after like 6 years of Discord. Not that long. Okay, MyPearson. Brian talks about using. Oh, you know what I didn't do this morning? I didn't put honey on my oatmeal. I was thinking about that. I've slowly put sugar back in my diet. Slowly. You're welcome, Miles. I'm a sugar addict. But you know, like honey's probably not that bad for you. I mean, it's like sugary, but a little bit of honey. It says it has like 32 servings, and I've had it for like a month. So why is everything locked? Marcus, let me go see right here real quick. I can fix it. Are you doing the auth? You have to go through the authorization. You have to do the authorization. I can see the auth channel right now. I'm so addicted to it. Yeah, me too, Elizabeth. It's good stuff. Check out this video. Oops, that's at Discord. So Marcus, go to the link at the end of this, and it'll show you your steps that you need to do. And then message me if you have problems, like email me if you have problems. Yeah, having a better diet has made me feel way better. Like I've seriously just like overhauled my diet. Like, oh my gosh. I'm mirror imaged. Piece of fuzz. All right, getting MyPearson up and going. Marcus, keep telling me if there's problems. We'll get it fixed up. We'll get you in. Assignment manager, we're doing all of homework 3 as Brian picks the lint off his shirt. Here we go, all of homework 3. Get that 100. Let's talk about it. We got 6 questions. All of homework 3 is going to be destroyed. Okay, MyPearson homework 3. 39, 33. Here we go. Stat 201. Let's check it out. Okay. I am taking right here. Fixing this. And thank you, Miles, for showing up. We're doing another 100 points for Miles swinging by. BS320 swinging by. Just say hey. BS320, always you can swing by here and say hey. Okay, so this is a contingency table. A contingency table is a bivariate display of categorical data. Please take a look here in the bottom corner where we have categorical up there as the y variable and categorical over there as the x variable. Mosaic plots are the visualization of it generally, stacked bar charts, side-by-side pie charts. All these things can be used right here. Mosaic plot, contingency table, and thank you to my wife for drawing that out so many years ago now, like 3 years ago. What percent of college presidents? So when we say of college presidents, we're talking about a what display? When we say what percent of college presidents? There were 1,055 college presidents. What percent of college presidents? What kind of display is that? When we say what percent of college presidents? Write these definitions down as we're about to do it if you know what this is. And good, Joseph, good guess right there. We'll throw you 50 points. Good guess. Good guess. We call it a conditional display because you're going within one variable called conditional. It's marginals are more univariate. Marginal is what we think of as a univariate display within the table. But what percent of the college presidents? So I think it was 1,000 something, 1,055. So we do 31 over 1,055. So we're going to do that out of the total. There it is right there. And we go 31 out of 1. There we go. And then once percent, so we're going to multiply by 100, copy, paste, delete down, and check answer. There we go. Does that make sense? What percent of the college presidents? About what percent of US adults think it's a good or excellent value? So this is very similar right here. We're going to take the same idea, and it is conditional because it's of US adults. I believe it was good or excellent. And we're going to circle those, and we're going to add them together and divide by the total. So make sure to know that this is also a conditional display where you look at the levels of one variable inside another. You set a condition. That's what conditional means. You're going to say, speaking of only the US adults, what do they think about these levels? Versus marginal would be like, what percent of people are US adults? What percent of people thought it was excellent? Notice how marginal is for everybody, and marginal is only one variable. Conditional uses both and looks at the distribution of one variable inside of another. So that is a conditional display right here. Let's add those up and divide by the total. So it's good and excellent, right? And times by 100. There we go. About blank percent of college presidents think the value is good or excellent. We're doing the same thing, but with college presidents. Once again, I'll draw this out so you can see. I want to make sure everyone has these step-by-steps. Draw more questions. We only have one more question after this, so if you're stuck on something, please let us know. There we go. 620, 177, and we'll add those and divide by the grand total of college presidents. Once again, this is a conditional display. This whole question right now has just been conditional, like, given someone's a college president, what do they think here? Given they're a US adult, what do they think here? Are college presidents not US adults? Notice that this is way higher percentage. So way higher percentage, leading to us to believe that there's some sort of dependency. Compare the distributions. On average, college presidents think it's a better value. So that would lead to us thinking that they are not independent. Is it reasonable to think? Basically, they're getting this from the data. Think provides an excellent value, and this is from the adults. This is one of my least favorite questions because they're just taking the 108, dividing by 2156, and timesing it by 100, and it's about 5.01%. If you take a look right here, 5.01, and the sample is representative. Let's see right here. The sample is likely representative of US adults, so the true value may be close to 5.01, but not exactly, because this is only an estimate. Which the answer is decent. What they're pointing to with this question, always think about what you're learning here, is they're pointing to that samples are used to make estimates about populations or make inferences. and they're having you do another conditional distribution but giving you the answer. So we make inferences about populations from samples. So, or they should just state that, like the 5.01 is a sample estimate of the population parameter, which is the truth. Know those terms. Sample is the data we collect or the people we collect on. Statistic, that's a statistic because we learned it from a sample. Population is the group we care about, the one we want to understand, and parameters, the truth. As in, when we have an election, they take polls, and if they say 47% are expected to vote for this candidate, that's a statistic. When election day happens, and let's say 51% vote or something like that, that's a parameter because that's the truth for the population. So statistics are estimates where parameters are truths. So it's like if you try your mom's cake and you say, this is a great cake, Mom, I give it a 9 out of 10, and then she brings it to a party and everyone gives it like a 5 on average. Well, she cared about the party's rating, and your 9 was a statistic, a very small sample size of 1. Maybe the family tries it and gives it a 9, so now we have a family. The problem is the family is biased and not representative of people at the party. So the family's gonna be like, yeah, this is great, and you might be biased towards the cooking too. I'm not saying your mom's a bad cook. My mom, I love you, Mom. My mom's all right cook. Oh, let's do this next one right here. Let's do this next one. My wife's an amazing cook, and I truly mean that. What is the conditional distribution and percentage of college presidents' opinions about the college? And notice how we're just going across college presidents. It might even be the same data. It's similar, but not exact. We're going to go across college presidents and do the distributions. And so now, of the college presidents, we just have to divide each of these by 1055 or so, is it? 1059. So take each of these and divide by 1059, and that's how we're going to get the answers. Who's in the chat? I'll throw out some 100 points. Just be like me or something, just so I can say hey to you. Because I hope people are having a good time. This is a busy work problem. Good to see you. Let's throw that 100 points. Ask another question if you want. This is right now is busy work. It's another conditional distribution. 100 points in the chat. Why am I not copying? Paste. Really? I gotta type it. 2.9. You might not get exactly 100% if you add these up because decimals. Apparently I can't copy into that. Me, it's good to see you there, Kylie, Elizabeth, Marcus, Alexander, Skylar. Thank you for being here. And if you want, get this one done. That's a lot. 59%. They don't make a math error. Excellent. 171 divided by 1059, 16.1. And then that's 29. Good, got it. Now this one's usually where people get stuck, and I want to explain why. Because what they're doing in this question is they're being a little weird. A little bit. Where's it? Okay. They are taking the data and they are really they're grouping it by saying for the US adults, they're doing the middle group is only fair. Okay. Here's how it's being grouped. So they're not going to use these answers. We have to remove those answers. So you have to subtract that out of the total. That's usually where people make mistakes. So our new amount of data will be what? How much data do we have now that we're removing those? You have to look at this right here. How much data will we have since we're removing those? 100-point answer in the chat. This is where people get stuck on this one. How much data will we have on US adults since we're removing the 62 from the 2,132 US adults? How many US adults will we have now? Since we're removing the 62, did not answer, not applicable, did not know. Out of the 2,132 US adults, we're removing the 62. Yep. How many US adults will we have in our sample? Great job, 100 points in the chat, you got it. So the denominator for all these is going to be, we add those together. Okay, so let's start doing it. That's how to do it right there. Add those together and then divide. Good to see you there, Cameron. Happy Monday. Thank you so much. Yeah, Cameron, 50 points. Former student right there, I believe. This is Cameron. I remember the cat still. It's like, and it's so crazy. Like, I generally can tell, like, current, former student, because, like, I miss my students. Seeing Cameron. Just love seeing people in the chat. Getting some points for the current students. Hope your Monday's going well. So, and if you ever graduate or finish the class, you can come by, say hey anytime. And we throw points for the current students. Currents are like, yeah, swing back by. And then the good excellent is going to be W points for class, more points. Cameron, I think you got really well. 750 plus 101 divided. We added the 750 and the 101. 41.1111111. Oh, sure, got it. That's it. That one usually gets people stuck right there. Pretty good question, just a little tricky on that last part. Just make sure, follow what I did right here, what I drew out visually. Subtract out, I got a 9 on my fall grade. Boom. Boom. Score 100 points to the class. Thank you for sharing that, Cameron. I was like, Cameron, throw them some advice if you want, Cameron. Because I think you're in office hours a good bit too. So throw them some advice. You know, like whatever advice you have for them, give it as we do this next question right here. Thank you, Cameron, for sharing that. That's awesome, man. I love it. And thank you for the compliment. I appreciate that. We got some stacked bar charts here talking about some categorical data. If you look, as people become more vegetarian, they are more liberal. That doesn't mean cause and effect, but we just see people who are more vegetarian are more liberal. Office hours, every single one. Yes, Cameron, that's what I remember. And then carnivore are more conservative, moderate, liberal, but there are liberals who are carnivores. And what does it show? Vegetarians tend to be more liberal than those with dietary preferences. I think that's about it, right? Yep. The differences are probably significant right here because they're pretty large differences. Stacked bar charts are displays of categorical data. That's the thing you should know from this question. Categorical data is displayed in mosaic plots, contingency tables, stacked bar charts, side-by-side pie charts. Differences are probably real and they appear to be strongly associated. The bigger the differences, like the bigger the gaps right here, the more real they are. Because if you were to say, do you think vegetarians and carnivores have differences in political opinions? At least the graphic shows that. Which independent would be more flat across where you don't see differences. So the more independent they are, the more they line up. The more associated or not independent, the bigger the gaps. And so those are pretty big gaps right there. We do have ways of doing this later with the chi-square test of independence. Strongly associated, be careful right there. Real differences show strong associations. Swedish men, and I believe they're Cancer. This one's a bit weird because it's such a small sliver, and this one gets very exact with what it asks. Notice a lot of people did not get prostate cancer. Very few people did get prostate cancer. Now this down here on the bottom is a what display. So 50 points in the chat if you can say it. Harder questions right here. It's only showing one variable is the hint. This is a what display of prostate cancer. See if you know it. That's a what display of prostate cancer, which marginal, 50 points, Elizabeth, you got it. That's the marginal display of prostate cancer. And you can see by the widths of the bars about what percent. Now, if you notice, it's about, that bar over there on the far side is about like 12 times longer than this bar. There's actually a very large window for answers right here. Just to show you, I think you can go as low as, because it's wondering about what percent of people got prostate cancer. So you have to figure out how wide this is, like what percent is this? Just take a guess, like this whole bar is 100% long. How, by kinds of charts. But yeah, down here, yeah, let's do it here. We'll talk about that. So this is just showing us by the widths, more people did not get prostate cancer. Does that make sense? This by this little width is showing us very small percent. So about what percent of this width is the yes? 10%? And you know what, Elizabeth? If you put 10%, you'd be right. You'd be wrong? Oh, I put 20. I've done this question a lot. I was like, I know it accepts 10%. I believe, and I'm gonna redo it here because I want to show you. 7's apparently the answer, but I believe it accepts as low as 5. I don't think it accepts 4. Does it accept 4? No. I think it's, well, where do they, because does it accept 11? It accepts 11. It accepts 12%. Here, we'll click the right answer this time. It does. The right answer says, yeah, so it accepts everything up to 15. It accepts 5 to 15%. So I think in 5% would have got a 2, Marcus. They're very, very nice in their window of this, which I'm okay with. I don't think it's a great test question, but 5 to 15% is a very, very generous window on what that is. I think I did it one time, and it's very close to 7% when you do it exactly. Like, I got very precise on it. So let's go right here and take a look. So the question is, what is this showing us? So what we have right here is a what graphic. For more points in the chat, you should know what kind of graphic this is. It's a bivariate display of categorical data. So what is the graphic called? For points in the chat, what is the graphic called? Just the name of it. This is called a what graphic? Not a box plot. Good guess right there. We throw points for wrong answers too. It's not a box plot though. Box plots, mosaic. Yep. So take a look right here. It's bivariate categorical. It would go with the contingency table. We're throwing less points for the right answers, 50 points for that wrong answer, only 20 points for the right answer. So it's a mosaic plot, And mosaic plots can show you the relationship between variables. So down here on the bottom, and sometimes over here on the sides, you get a marginal display. Repeat after me. The marginal displays are in the margins. They're on the sides of the table. This one does not have a second marginal display. I'll show you one really quick here in Jump that has a second marginal display where you can see both marginal displays. We go back here to our Pokemon data, and this one might look pretty crazy, but analyze fit Y by X, type 1 with legendary, and now here you see it. Does everyone see the marginal display over on the one side? Here is a marginal display. Over here, it's outside the table. We find the percentage of a certain answer on a mosaic plot beyond exam. Yes, conditional distributions are definitely like the Canvas contents on the exam. Kylie, great question, 50 points. Yes, the conditional distributions are on the exam. A lot of people get this wrong. And you see the conditional down here. Marginal. So does that make sense where the marginal distributions are at? And they display one variable. The bottom axis right here is letting us see not that many Pokemon are what? Not that many Pokemon, due to the widths of the bottom of this, not that many Pokemon are what? And you know what? This is pretty interesting. Not that many Pokemon are what? Then we're going to answer our question, but this is good on review of mosaics. Not that many Pokemon are what? We're only talking about one variable in the marginal down here. Not that many Pokemon are what? As you see, the width of this is very similar. Legendary, which means true that it is legendary. And look at this. A lot of legendary Pokemon are overrepresented by being what type? I didn't know this. A lot of legendary Pokemon. Is this the full data set or a subset? Oh, it's the subset. I want to do the full data set now. A lot of legendary Pokemon are overrepresented by being what type? Which is interesting. A lot of legendary Pokemon are overrepresented by what? Psychic. There's a 21% of legendary Pokemon are psychic, and 18% of legendary Pokemon are dragon. So dragon and psychic have a much higher percent within the legendaries. Does that make sense? So I didn't even realize that, but apparently I guess dragon's cool and psychic's cool. What's not cool? We'd have to go to one that has shrunk down in percentage, probably like normal. Like what normal psychic Pokemon? Someone probably knows at the top of their head. But you can see, yeah, normal I think is right here, and there's normal, and then the normal legendary, and we can actually subset. A normal legendary Pokemon is Reggie. Which Reggie is that? Regigigas and Arceus. I didn't know Arceus was normal. Huh. Interesting. So this lets us see, this is the what distribution of legendary Pokemon. So this is like this percent right here I'm getting. This 21% of legendary Pokemon are psychic is a what distribution? Points in the chat if you can say it. 21% of legendary Pokemon are psychic is a what distribution? 21% of legendary Pokemon are psychic. 21% of legendary Pokemon are psychic. What distribution is that? That's called a what? That is called a what? We just did the marginal, which is on the sides and only looks at one variable. 21% of legendary Pokemon are psychic is a what distribution? 21% of the legendary Pokemon are psychic. So you're looking at both variables and you're looking within it. I'm going to give it another 10 seconds here. Conditional, Joseph earning everyone 50 points. Conditional. And so if you understand how to talk about this stuff, and great job, Marcus and Elizabeth right there. Don't worry about being wrong. Just answer questions. I'll throw points right or wrong answers. So does this make a little bit more sense, I hope, when you look at this? Like, of the people who had prostate cancer, what was their fish consumption? Of the people who did not have prostate cancer, what was their fish consumption? And the fish consumptions look basically what between these? They look pretty identical. This one, it shows that there's a lack of a relationship between getting prostate cancer and your fish consumption. It looks like they're independent because they're very, very similar. They don't have to match up perfectly, but they're pretty similar. The questions they ask are a little bit different. Let's look at their questions. The questions they ask are the percent. It's basically 7%, and we did this one a moment ago. They're looking at the width of the bar at the bottom right here for the yes category to figure out about what percent got prostate cancer, the marginal display of prostate cancer, and the percent yes. There are more men who never seldom ate fish. Now be careful. Are there more men who had cancer and never seldom ate fish, or more men who did not have prostate cancer who never seldom? This one's tricky. They're asking the amount of data within this gray bar and the amount of data within this gray bar. Would you rather have gray bar 1 or gray bar 2 if it was gold? So pretend gray bar 1 is gold and pretend gray bar 2 is gold. Which of these gold sticks would you rather have? And you can melt it down. So you're just thinking about area right now. Like, which of these takes up more space? Gray bar 1 or gray bar 2? Gray bar 1, which means that takes up, there's more observations in there, although it's slimmer. There's more data in there. Does that make sense? I don't love the question. It's just which group has more data in it? It would be the did not have cancer group. The way they ask, it's a bit weird, and we've never made a test question just like that. The percent of men who never... Okay, so this one says, which is higher? The percent of men who had cancer who never seldom ate fish, or... And notice what they're doing right here. This is conditional. Given someone got cancer, what percent never seldom ate fish? And it's the gray bar again. Given someone got cancer, so which has a higher percent? So is it 1 has a higher percent and is like takes up more height in this within the no, or 2 has a higher percent? That's what they're asking right here. They're asking conditionally, which has a higher conditional distribution answer? Is it gray bar 1 has a higher conditional, like has more percent within the height of this? Now it's 2. Does that make sense? So that one's actually the conditional. Like, given someone had prostate cancer, what's the percent of never seldom ate fish, which is the height of it? Given someone did not have prostate cancer, what's the percent within it? So conditional. But those are the terms we need to understand. So it would be with cancer right there. Not my favorite question the way they ask it. Not my favorite. I've got better. Some of the other ones were great. Here we go, looking at the same data we looked at a lot right here. And notice, is this a strong, weak, or moderate relationship between views on college and somebody's status group, like the adults or president? Is this a president of a college? Is this a weak, non-existent, strong, or moderate? What would you say? Relationship between the two variables. What would you say? Strong, weak, or moderate? I'd say super duper strong, right, Alexander? Right there. I'm dropping things on the ground. It's so strong. I can't even control myself dropping things. It's very, very strong. Great job, Alexander, right there. And yes, because there's big gaps. College presidents were way more likely to think it was what or what. College presidents, given someone was a college president, the conditional distribution of college presidents had a much higher percent of people thinking it was what or what. So the conditional, look within college presidents. Good or fair? Good answers right there, Marcus. 50 points. So you about saying good morning. Good or excellent. Good or excellent, because the purple and the green are much bigger right here, where U.S. adults were more likely to think poor and only fair. Does that make sense? So given somebody's group, it probably shows evidence or is related to their view on college. What college president thinks it's a poor quality? Go work at another college if you think that about your college. So for the mosaic plot, about what percent of the respondents were college presidents? So if we want to see of the respondents, what percent were college presidents, put a C or M in the chat. Is that conditional or marginal? Of the respondents, What percent were college presidents? C for conditional, M for marginal. Is it C or M? Of the, I'll be careful. Conditional will always have two variables. So of the respondents is of everybody. So it'd be marginal. We're throwing 100 points. Don't worry about those wrong answers. It's a marginal display. So where should you look? In the margins. You see how we're looking like down here at the bottom? And what do you think? Give me a ratio, or say about this something, like a percent or something. About what percent were college presidents? Because it's in the margin right here. This is the marginal. These are conditional within here. Within the table is conditional. On the sides is marginal. 30, 33%, right? About a third. Does that make sense? Like this is about 30%. That's about 70%. I think 30% will do it. I think it's about a third. So if we do 30% right here, I bet it'll accept it. It's got a big window, but. And the window for it, I want to see the window for the answer. The window for the answer is 33 plus or minus 5%. So you should be good. I think it's very fair. It's once again a big window. So you could go up to 38 and you'd get it because it's within the window of acceptable answers. From the mosaic plot, is it easy to see there are more US adults who said college provides excellent value, or more presidents who said? Now this is on the counts. This one is once again one I don't love, so pretty much look at the answer right here. This goes back to the previous one asking about how many people are in each group. So would you have more of a gold bar if you had gold bar 1 or gold bar 2? And it's the area of the gold bar you care about because you can melt it down. I don't love this. It's not my favorite because we don't usually look at it that way. Like if you're really hungry and I cut you a pizza slice like this or a pizza slice like this, would pizza slice 1 have more pizza, that purple bar right there, or pizza slice 2 have more pizza in it? I don't know. Pizza slice 1's really long but narrow. Pizza slice 2's wider. I don't know. They look kind of similar in size. I don't love this question, hence why I'm not going into so much detail on it. It's not easy to compare the area of the two rectangles. It might be 2. The answer to this one is it's not easy to compare the rectangle here and rectangle here in area to know which has more. Don't love that one. From the mosaic plot, is it easy to see how the percent of college presidents who said it's an excellent value differs? Now, to look at the percent of college presidents, we're looking at a C, conditional, or M distribution. The percent of college presidents. We're trying to get this down today. Practice it. The percent of college presidents, is that conditional or marginal? The percent of college presidents who think it's an excellent value. Careful, Alexander, 100 points again. In grade of Joseph, Alexander got the points though, and so did Marcus. It is, and it's going to be conditional, because the percent of college presidents who think it's an excellent value. Let's draw on this real quick. If we are doing marginal, marginal will always be in the wheres, and it only does one variable. Marginal will only be in the margins, and it'll only have one variable. And it can be on the sides too. Great job, Elizabeth, 50 points, good answers. And conditional is going to be the within. So do you see the within adults, what do they think about this is conditional? Like given someone's an adult, given someone's a president, or for the presidents, what do they think about this? That's conditional. There can be an additional marginal display on the outside, as we saw with jump a moment ago, which would display one variable. But the marginal displays display one variable, and they are on the outsides, where the conditional displays look within one of the variables to give you the distribution of the other, so they're a bivariate idea. Oh, no worries, Elizabeth. Thank you for being live. 50 points for being live. You're still getting those points right here, and thank you for following along. Good stuff. Yes, because the width of it. Yes, because the proportion's easy to compare. I think that's it. Kind of read it quickly, but I was like, yes. From the mosaic plot, do you think there's an association? Yes, because they're very different. The more different they are, the stronger the association, and we talked about that to start. That if they line up really close, it's a weak or non-existent. Blakely, great to see you here. Weak or non-existent, and the more different they are, the stronger the association. Let's take a look right here. This one's crazy. Good morning, Blakely. This is not a bivariate display. This is a trivariate display with gender, political view, and diet on display. And I get this one wrong sometimes because it's a little bit crazy. We never put a trivariate display on class, but everything here is categorical, making a trivariate categorical mosaic plot. Are there more men or women in this survey? It's very clear to see this. The widths of the bar for the M's is what are to every width of the bar for female respective. When you look at liberal, moderate, and conservative, the widths of the bars for M is more what? It's wider. So there are more men. There are more men because the total of the bars labeled M is larger. I think it's weird. I'd say the widths of the bars. Good. Does it appear that there's an association between politics and gender? This is the one I hate because you should display this differently. Like, this is not well displayed for this answer. If you look, the female bar as a ratio gets wider as to male. Like, if you think right here, it's a little, like, it's about 60% the male size. Here it's about 30% the male size, and there it's like 10% the male size. So as you get more conservative, there's what females? Percentage to male. Where here it's like female gets smaller, right? So we're looking as the width of the, this is not a good display for this, Pearson. The graphic, you got too many variables. Made too complicated. No, just do gender and political view. That's what we should do. 100 points. Thank you for everyone in the chat. Love those answers. We keep throwing points as you talk, so keep talking. There appears to be a, I think it's strong. I've gotten this one wrong. It's either weak or strong, because the females become smaller. Yeah, it's moderate-ish. Don't love that one. If it stayed the same, it'd be weak / non-existent. The bigger the differences are, the stronger it is. If someone made this graphic, I'd ask them to remake it. Like, I'd be like, just show the two variables. Why are you showing a third variable? Are the in-person 1 to 3, Kate? Swing on by today. Thank you for asking. In SMC, floor 2. There appears to be, okay, so let's go look at diet and politics. Okay, so conservatives are not what? Apparently. Very few to no conservatives are what? Very few to no conservatives are what? I'm blocking the answer. Look over here at the conservatives. Vegan or vegetarian, right? Vegetarian, vegan. And then the vegetarian vegans, doesn't mean all liberals are. MyPearson making up some data. It's going to be the more liberal you are, the more vegetarian you are. And then you can see carnivore starts to increase over here on the more conservative side. You're welcome, Kate. And so there appears to be a, we'll go strong again, because the diet tends to, as people become more conservative, include more meat. Go strong, we did it. And what's the last? Last one is, oh, I was zoomed in too close, sorry. The differences between this, right? Does the association between politics and diet seem to differ between men and women? Kind of. Women are generally more what-ish. I mean, look at the one thing, I love a good steak too. We're going to a fancy restaurant for Valentine's Day or early Valentine's Day. How do you get your steak cooked, Joseph? So women tend to be more what according to this data, and men tend to be more what? Like for each group, women tend to have more this, where men tend to have more this. Medium, I'll do a medium. Try a Pittsburgh medium if they'll do it. Pittsburgh medium. Got it right here, do that. Show you the best steak right here, Pittsburgh medium. That's Pittsburgh medium rare. I've seen tons of Pittsburgh medium rares on here. Not a Pittsburgh. I'm a Pittsburgh. Oh, that is good right there. Copy image. And so we'll finish this now. I'll show my steak, my preferred steak. Okay, the difference between is the difference in proportion of vegetarians between liberals and conservatives is larger for vegetarians, larger for women. The difference in proportion of carnivores between liberals and conservatives. More men, right? This last one. I just don't like the way that's worded. I don't like it. Oh my gosh, got equations over that. Here is a, Pittsburgh is when they burn the outside of it a little bit. So Joseph, if you ever want to try Pittsburgh, just some people will burn it up on you though, so you got to watch out. You might be like, I want it Pittsburgh, and then it'll just burn your steak. I mean, it's going to be crispy outside, That's a good steak right there to me. Looks, I know it does. And then problem is some people get like Pittsburgh rare. I could not do. Someone's gonna freak out over that. There's Pittsburgh rare-ish. That is way too rare for me. This is safe to eat rare steak. Ooh, this one might be someone's home steak or something. Ooh, that steak looks really good right here. I'll show one more steak right here. These two steaks, this is about perfect for me right here. Not that. But these two steaks right here, whoever made these two, that's about a perfect. So you get that sort of, yeah, that last one, this is good. That's a good medium rare for me right there. I would say it's almost got a little bit of red in the center. It might be medium rare right there. And then you get this nice sort of crust on the outside. And so it just depends on how thick of a steak you're cooking too. It's gonna be harder. Like that is too rare. That is, I don't think that's blue rare, but that's rare. It's rare. That's a medium rare, or maybe even towards medium, because the picture, it's hard to, it might be medium-ish, it's medium rare. Those are solid. I know right there, like that is, so try it if you want some time. Chop House has really good fillets. They're like $28 now. But I mean, Ruth Chris, go to Ruth Chris, fine. Over here. We got another topic to do now. I think Ruth Chris is overpriced. Like, I think you can get a good steak. We're gonna do canvas content next. You can get a good steak for not a ridiculous price. I mean, I know 20 something bucks is a lot for a steak, or low 30s for some people. I mean, believe me, I had a time in my life when I was trying to find a dollar to eat a chicken sandwich. But Longhorn is your go-to. I should check out some Longhorn. Look at that Longhorn menu. Go look at Longhorn, then we'll do the canvas content. Points. Asking me to find my location. Knoxville West Town Mall. Order here to go. Gonna get my steak. Oh, they got good prices. They got a Flo's filet for $25. Dude, Joseph, I might go to Longhorn and get myself a filet for 25 bucks. Do you only get the filet? I'm adding it to my cart right now. Is that it? Wait. Do you not get potato or anything with it? Yeah, you do. Okay. It won't let you do right here. Okay, choose a side. Loaded baked potato. Oh. Choose an additional side required. Salad. You get potato. 25 bucks. You get potato and salad. And you get a 9-ounce filet for 30. Not bad. I am so hungry right now. Renegade sirloin 15. Not bad. New York strip 25. A lot of people like the New York strip. T-bone for 29. The Longhorn Porterhouse for 34. I need to tell my wife that we're gonna go to Long. Hi, Alexander, or Joseph, excuse me. 50 points. Some good stuff right here. You get 6-ounce with lobster tail for 34. Not bad. Fine dining's overrated. Linton's good too. Linton's Knoxville. They got the burgers, right? Everyone loves Linton's burgers, which they're good. I haven't been there in a while. Got Linton's, good stuff. They got the charbroiled chicken or hamburger steak. Linton's is like some classic stuff. Oh, $7. Go there. Canvas content number 2. Let's do it. I'm just hungry for lunch. I've been working out too much. I need food. Need food. If it ain't moon, it ain't chewing. I need the first one. Do today. Let's do canvas content. Do today. I'll remind you. Okay, here we go. Oh, number 1. Okay, let's do both canvas contents. We're here. You're here. You get to ask. Canvas content number 1. Okay, you ready? Another chill song. I'm getting it marked. We took our little break. If it ain't mooing, we ain't chewing. Bye. What's up, Amy? We're about to do canvas content number 1. Here we go. Let's go do it. Okay, we're gonna do both canvas contents. Perfect timing. You got it. And anytime you come here, just ask to do a question. We'll put it in the list. So what people do is they just say, hey, Brian, can you do this? And then we add it to the list. So please just ask. It'll be in here later. Like if you can't stay, I can always add it, and then you can come back and check it out later. Okay, so here we are with the preview of what's going on. Just swing by in office hours if you're watching this in the future, and just be like, hey, Brian, can you do this question? We'll do it. Preview. Here we go. We do statistics called what statistics. So don't worry about answering true or false. I'm quizzing you. We do what kind of statistics? Hence, it makes these. Canvas content number 1 due today, Elizabeth. Is Canvas content found on Canvas? We do what kind of statistics? Called something with an I statistics, because we use it to understand a population. Statistics are used to understand a population. Inferential, so we make inferences about a population. Inferential statistics. A sample is what you collect. Remember SSPP, because we say sample statistics give us inferences about population parameters. We gave an example earlier, but before an election, you take samples of people, you get a statistic on the percent you think will vote for somebody, and then you get the parameter of interest for everybody, which would be the percent that vote on election day for a candidate. And the parameter is the truth. Like on election day, 52% of people voted for a candidate. That would be the parameter from the population. The percent of people who like the candidate or vote for the candidate in the sample are going to be a statistics. It should be under the home. If you click under home and scroll down, it should be on your list of assignments. If you scroll down to home, you should see it right here under Canvas content number 1 due today. So check it out. You might have already done it. And then the next one says, what type of variable is player ID? Now, before looking at the answers, how many, and include the special one, how many types of variables are there? Before looking at the answers, how many types of variables are there? Don't look at the answers yet. Don't look at the answers. How many types of variables are there? There's 3. Amy knows right there with 50 points. We have quantitative and categorical, which are the main 2. And then we have identifiers, which are special case categorical variables. Now, quantitative has to be numbers. Okay, so this could be quantitative. Categorical can also be numbers. But identifiers, which this has ID in it, identifiers are what variables that can never what. So identifiers are special case, I'll say it because I want to get everything done. Identifiers are special case categorical variables that can never repeat. Never repeat. Amy knows right there with 50 points. Identifiers. So player ID in a data set is going to be an identifier, like your student ID number. It never repeats. Your social security number is an identifier. Your license plate is an identifier. It never repeats. License plates can also have letters in it. Identifiers can have numbers or letters, as can categorical variables. Team is categorical, position is categorical, club is categorical. Yes, because these are the players. The club will repeat, position will repeat, team will repeat. Height and weight are quantitative because they represent how much in a quantity somebody weighs. Those answers. The type of data that puts people into groups. So that's why I like saying groups are basically just what's. Groups are basically just what's. The type of data that puts people into groups, categorical, and special case categorical is identifiers. So technically it's kind of right, but don't click that. Now we need to know different types of charts. You can make a what of your favorite pies, and you can make a what of your favorite bars. That's why I have the arrows right here, so we never mix them up. They go together. You can ask somebody their favorite pies, make a what of this. You can ask someone their favorite bars, and you can make a what of this. Pie chart your favorite bars, bar chart your favorite pies. Exactly. I have to do it because someone hasn't seen it.
Bars. This is a pie chart describing my favorite bars. And this is a bar graph describing my favorite pies.
Pie chart your favorite bars, bar chart your favorite pies, and both those questions are categorical in nature. Great job and answers in the chat. So both of those are categorical. Now a Pareto, because maybe he did it it's a good question because it'd be for him. He could have done it by how many times he ate the pie, because he could have looked at what pie he was eating. Like maybe he goes to buffets or whatever. He goes to like Thanksgiving and he's been tracking for years, like the pie he eats. So you're counting like the counts or frequency of observations of you eating a favorite pie. So he's just been tracking like what bars he goes to nightly and what pies he eats when he eats pies. So favorite would be the ones that show are the ones you eat most often. Because yeah, Alexander, I love that in-depth question because I actually wondered that too a while ago. Like, wouldn't you just have a favorite pie? So like, how does a pie chart show his favorite bars? So all you would do right here is you'd collect data, and you would go and you would say, what bar did I attend tonight? And you would say like leaderboard, baseball leader, half barrel, barcade. And then you'd go here, you'd go analyze or graph builder, throw it in here and go and make a pie chart of it. And there you go. There's a pie chart of my favorite bars measured by how often I attended the bar. Does that make sense? So there's a bar chart, a pie chart of my favorite bars. So you'd have to record the data like that, like how he attended it. So a pie chart of my favorite bars. Really good. I wondered that a while ago too, because he's not very explicit in how he says it. But good question. That's how we make a pie chart of our favorite bars. A Pareto, say it with me and have this on a note card, is just a bar chart that has been put in what? A Pareto is just a bar chart that has been put in what? Here's a bar chart and a Pareto chart. Here's a bar chart, which is univariate categorical. A Pareto is just a bar chart that has been put what? There's the Pareto. So here's a bar chart. Here's a Pareto. It has extra stuff, but mainly the bar chart must be in what? In order. Pareto means put them in order. So a Pareto is a bar chart, so it's categorical. It's a bar chart put in order. Histograms and stem and leaves are both quantitative because a histogram has the quantitative axis on the bottom, and then a stem and leaf just shows you the actual numbers. Notice how you can really see the two outliers right here for 185, 180, 190, and 15 attack power. What Pokemon is this? The weakest Pokemon in my data set is going to be Feebas. Feebas right there. That evolves into that, that fish type Pokemon evolves into Militech or something like that. So that is the weakest Pokemon in my subset. Not Magikarp today. You know what? I'm always wondering, what is the weakest Pokemon? We could sort it in the full data set. So the weakest Pokemon, and we can actually see its strength. So we can go to attack power of all Pokemon, all 800, stack it. Now the problem with stem and leaves is they show you too many data points if you do this. These are the weakest Pokemon down here, and it won't let me multi-select. So one of the weakest Pokemon with an attack power of 1 is going to be table subset. It is Shuckle. Shuckle right there, one of the weakest Pokemon with an attack power of 1. Probably Magikarp and others, weakest Pokemon. So stem and leaves lets you see the data points. Histograms are just the bins, and a box plot also. Take a screenshot of this graphic if you don't have it. Notice how histograms, box plots, stem and leaves, and dot plots are all right there. Because as I select these, they are all quantitative displays of data. The median is highly influenced by outliers. Tell me the median of this data set. 1, 3, 5. What's the median of those three numbers? 1, 3, 5. Yeah, tell me the median number. 1, 3, 5. 3. Now let's make it an outlier. 1, 3, 10. What's the median? That's the nose of ground. 3. What's the median of 1, 3, 100? So the numbers are 1, 3, 100. The median is not being impacted by the outliers. What's the median of 1, 3, and the next number, a billion? It's false. The median is not impacted by outliers. The mean and standard deviation are impacted by outliers. The median and IQ are not impacted by outliers. So really good quiz. We'll do one more version. We'll go a little more quicker this time. Submit quiz. Get that 100. I've done this quiz a lot. Is it gonna? There we go. 100. Yeah, 10 out of 10. Okay, let's do it again, and then we'll do quiz 2. Good work here, everybody. We'll probably do more of the MyPearson next time too. But preview. Here we go with version 2. Okay, the variable average chocolate rating. Now, if you see numbers and you can do math on them, they are quantitative. Is this categorical, quantitative, or identifier? Is it categorical, quantitative, or identifier? Which one do you think? Quantitative, because you can say, because think about this, if you would say, whatever this is, Caribbean's chocolate was 0.7 higher than Chocolate Alchemist. Does that make sense mathematically? Like, does it make sense to say, like, Oh, Caribbean has a 0.7 higher rating than the Alchemist rating of 2.5. But don't worry about repeat. But repeat is only if it is identifiers. Amy, good answers / questions right there. It is quantitative because it represents actual real numbers. So quantitative data is actual real numbers that you can do mathematics on. Does that make sense, Amy? Quantitative is actual real numbers that you can do mathematics on. And they could repeat. Repeating is not really important for them. Only when it's categorical do we care about it being identifiers, which company name is probably the identifier because we're rating all the chocolates of a company and getting the average rating for that company. So the company wouldn't repeat. Company name is identifier. Average chocolate rating is quantitative. Darkest percent cacao is quantitative because you can say they have a 30% higher. Company location, is company location identifier or categorical? So type I or C in the chat. I or C, is company location identifier or categorical? It's categorical because two companies could be in the same spot. Even though it doesn't repeat here, two companies could be in the same spot. Does that make sense how to see that it's categorical? Because two companies could be in Peru. Even though it doesn't repeat, because some people are like, it didn't repeat. It's like, well, it could repeat. Small data sets don't often show the non-repeating nature of an identifier, but you have to think theoretically could it not repeat. Thank you, Caden and Kylie and Samantha, throwing 100 points. The type of data that represents actual real numbers is what? Say it with me again. We're gonna do Canvas content 2 in a moment. Get those hundreds. Tell me if you have one you haven't seen yet. Put it in the chat. I'll answer it directly. If you have one on Canvas content 1 that we don't see yet, just tell me in the chat. That's quantitative. Yep. Quantitative variables must be numeric. True or false? Like if something is a quantity, it must be a number. If something is a quantity, true. Yep. Can categories be numbers? Can they be? Like, must they be? No, I'm saying. Can categories be numbers? Like you're in group 1, you're in group 2. Yes. It doesn't represent how much your group is. Like your group doesn't have a quantity of 2. It's just that your group label 2. Which type of crime was least frequent? Look to the pie slice. That's the smallest. It's violent. Pareto is a special case what? You get this one you're like, psh. Pareto. That's a Pareto. Is a special case what? And these are all. Oh my gosh. Oh my gosh. Those are all categorical in nature. Bar chart. Yep. Paretos are special case bar charts. They are put in order. That was the one you were seeing right behind me right there. They're special case bar charts put in order from most common to least common. They have extra like cumulatives and stuff. Drop a question in the chat. If I didn't do it, I will answer it directly. If you have like a true false or anything for Canvas content number 1, let me know. Just say it. I'll answer it directly since you're here, and I appreciate it. I appreciate you being here, getting this work done. Just get it done. Say, hey, Brian, do this one. We're gonna do Canvas content number 2. We did a lot today. Let's do Canvas content number 2. Do a week from today. So Canvas content number 2, starting up right here. Take those notes. Chat 201. Canvas content number 2. Okay, here we go. With this, let's go ahead and go to the preview of it. We'll do this 2 times right here for Canvas content number 2. Which vegetable had the highest? Well, there's that. But also, I do want to point this out. We'll just mention this. Whenever you are looking for highest or lowest, don't forget what's is for 100 points. Whenever you are looking for highest or lowest, don't forget the what's is, which we haven't done in chapter 4. We'll be doing it next class. Whenever you are looking for highest or lowest, don't forget what's is. Whenever you are looking for highest or lowest, don't forget what's is. For 100 points, remember this on the test. Whenever you're looking for highest or lowest, don't forget the what's. Outliers, Samantha, 100 points right there, the outliers. So broccoli would be the answer for this one. Let me get the, don't forget outliers. A lot of people forget it on the test. They just look to the top of the box, which is not the maximum value. Blocks. Box plots are not ideal for comparing multiple groups. Let me show you. If I want to look at the attack power of Pokemon versus type, what I could do is I could look at it this way. Analyze, distribution, attack power, type, right here. These are called stacked what's-is. These are called stacked what's-is. Now they have uniform scales. Always do the same horizontal scales. Stacked what's-is. Locking, I like that. Thank you, Blakely. Stacked what's-is. These are called stacked what's-is. Because it's quantitative categorical. These are called stacked what's-is. Because they're stacked on top of each other. These are called stacked what's. Histograms, stacked histograms. Now tell me, is it easy to compare these? Not so much. Those are stacked histograms. How about though, if I go here to attack power, type, now, these are called side-by-side what's. We can do it a little bit better probably too. Those are called side-by-side what's. Side-by-side box plots. Great answers in the chat. Amazing points. We got a lot of points on today's office hours. So these are side-by-side box plots right here. You can also add in the 5-number summaries to them, and this is ridiculous though because there's too much. Try to make it smaller. No, it's not wanting to make it smaller. My tricks for there we go. This might be too much data to display. It's getting really mad, but you can see like Psychic has the highest one is an outlier. It looks like over here. It's hard to tell which one's the highest because of that. There we go, 190, and this is that also 185. Okay, might be Mewtwo or someone, I think it was. But easier to compare these, and you can see like Electric doesn't have much attack power. Man, Dragon, strong attack power. Dragon has the highest median, so that's interesting. Fun fact here right there. Dragons have the highest medians, where things like Electric have the lowest median. So, and probably due to the skew nature of the data, we'd want to use things. So are box plots ideal for comparing a lot of groups? Are box plots plural, side by side, ideal for comparing multiple groups? Like, can I compare groups decently with this? Can I do better comparisons with this and compare these groups? I'd love it if they went in order. Can I do comparisons between these a little bit easier? What do you think? Do you think I can kind of compare them better than I can scrolling through all this? Like, what's easier, scrolling through this to compare? Yeah, so these are side-by-side box plots. These are stacked histograms. Side-by-side box plots. Also, hint for the test. Box plots can hide things like the shape. So remember this for the test. Write it down. I'm literally talking about a test question here. Box plots can hide some features of that a histogram would show. Box plots are good for summarizing a lot of stuff at one time, but they hide some important features that histograms will show. Sometimes we can remove an outlier. We've had people say that they study 20 days a week, and I remove that outlier because they're going to be way outside of the rest of the data. Someone who says I study 20 days a week, can I remove their data from my graphic? They're an outlier. Sometimes you can remove them, yes or no? And you remove someone who says I study 20 days a week. Can I remove that? What do you think? And you remove outliers. You can, if it's lies, if data is misentered. Good answers, Joseph right there. If data is misentered or it's lies, you often, and here's something to write down, you will often write that you removed it, and you might do the analysis with and without it to show the differences. So a good habit is to say that you removed it, and then unless it's like completely a lie or impossible, then you do the data with and without it, and you say, with the outlier, here was the mean. Without the outlier, here was the mean. We've chosen to remove the outlier, and thus the average for the data set is this. The reasoning for removing the outlier is this. Like, you give your reasoning, you give your context, and there's sometimes a good reason. Do the analysis with and without. That's also kind of on the test too, hence why I'm mentioning it. Sometimes a good reason to remove. Do the analysis with and without. Thank you. Good answers, everybody in the chat. What percent of Marvel superheroes have the ability to fly? Type C or M in the chat as I show how to get this answer with that beautiful steak. What percent of Marvel superheroes? C for conditional or M for marginal? What percent of Marvel superheroes have the ability to fly? Is that conditional or marginal? What percent of Marvel superheroes? Conditional or marginal? Conditional means we look at the distribution. Why is the of here important? Because it means within. Like, given someone's a Marvel superheroes. Thank you, Alexander, for asking. So you're saying right here, of the Marvel superheroes, so you're only doing that one group. which looks at the only Marvel superheroes, and then the flight. Can anyone find the mathematical answer right here on the screen now? So use the numbers on the screen to find the answers just real quick. I lost one of my favorite songs because I got copyright claimed on it. Great job. I think that's it. Yep. Type it in the chat if you want. Samantha, more points. Great work, Samantha. That is it. You got it. People are telling me the answer in the chat. And it says do it as this. You have to put it like as a percent without the sign. 14.5. And this one people get wrong a lot. What percent were neutral? Maybe they don't. It's not this one. There's a different one. It's like of the dark chocolate likers. So what percent were neutral? How many variables are mentioned right here when we say what percent were neutral? Do you hear one variable being mentioned or two variables when we say what percent were neutral? When we say what percent were neutral, how many variables are being mentioned? One. So that makes it a what display that we're trying to analyze. This is a what display we're trying to analyze. Great job, Amy, also. So what kind of display is this? I'm highlighting the answer below. Think of where it's at. Once again, this is in the margin. So we call this a what display, or like we're analyzing the what display. So there's the answer. Marginal, great job, Kylie, right there. It's a marginal display, 229 over 992. What does that equal out to? So it's a marginal display because you're not looking within variables or within the table, and times this by 100. I think we do accept a lot of the answers that are 23.08, and it wants to 2 decimals. And last but not least, what is the probability of a student born in Tennessee being an honor student? So think, is it looking within one variable at another? So a student born in Tennessee being an honor student. Of the students born in Tennessee, what percent were honor students? So I'm going to give you a try at this. See if you can figure this out. Of the students born in Tennessee, what percent were honor students? Of the students born in Tennessee, what percent were honor students? See if you can answer it to practice. Of the students born in Tennessee, what percent were honor students? See if you can do it. Of the students born in Tennessee. Great job, Amy. I think Amy got it. We're throwing 100 points for Alexander and Amy giving this a shot. There it is right there. 9-ish% or 8%. Great job, Samantha. And also Alexander earning, we threw 100 points. I was going to throw 50. Once again, you know, we're throwing another 50 around there because I'm being serious. Keep those answers coming. Don't stop trying. Don't worry if you get it wrong. 8.3 decimals. W right there. People get 100? Tell me if we didn't do your question. We should really. Which one did I get wrong? Did I do a decimal wrong? Did I misclick? Oh my gosh. Okay, does anyone remember why I got this wrong? Because what did I say when I was saying it? Please don't get this one wrong. Have a great day. Oh yeah, and then Alexander will show it. So why did I get this first one wrong? Does anyone remember what I was saying? I misread it. I kept saying box plots are ideal. So please, if I'm your teacher, let me know and I'll try to fix it. Hopefully I don't got a billion things to fix. But I kept saying box plots are ideal. They are good for displaying multiple groups. So I kept saying, yeah, they are good. And I was reading in the true sense. So, oh my gosh, do I have the music tool out again? No, I don't. Okay. No, I got the music tool. All right, Joseph, misread a question. The last one right here is conditional because, thank you for asking, we're saying of the people born in Tennessee. So that only looks at those. Does that make sense, Alexander? Of the people born in Tennessee, what percent are honor students? But there's different ways to read it. You could ask, let me ask you this. What percent of people were honor students born in Tennessee? So let me write this in the chat. Answer this. What percent of people were honors students born in Tennessee? Find this one out. Who's got this? What percent of people were honors students born in Tennessee? What percent of people were honors students born in Tennessee? All the math on that. What percent of people were honors students born in Tennessee? How do we solve that? What percent of people were honors students born in Tennessee? Great job, Joseph. That is correct. And then look at this one. what percent of honors students were born in Tennessee? Now look at this one. What percent of honors students were born in Tennessee? So think how we would solve this. What percent of the honors students were born in Tennessee? That's interesting. Great job, Joseph. Yes. And do you see you would go of the honors students? Does that make sense? And Alexander, does that make sense? What percent of the honors students, so you're only looking of the honors students, were born in Tennessee? So compare this one to what percent of people were honors students born in Tennessee. Next two versions, when comparing histograms, yeah. When comparing histograms, make sure they have the same horizontal axes, and outliers and box plots are 1.5 IQRs above and below Q1 and Q3, 1.5. Let me go do another version though, Blakely. Blakely, 100 points. Thank you for being here and thank you for asking that. I'm just dropping you some answers and we're gonna go review it here. And please ask those questions. We're gonna answer all of them. And if you're here, you get your answers directly. You do more, yeah, let's do another. We're gonna do another version of this as practice. And yeah, Joseph, anytime, man. Glad to get those hundreds. Swing on by. Here we see a data set and it wants the 75th percentile. The 75th percentile of a box plot is going to be the top of a box. So when you're looking for the 75th percentile, you are looking for the top of the box. So the French team's 75th percentile is going to be right here, which is 190. And that's where the 75th percentile is for any box plot. So this one is 190. That's where it's at. Very clear. There's sometimes a good reason to remove outliers. Very true. What is the probability of a student being born in Tennessee? So is this C or M? Alexander, good practice right here. Marginal means it's only one variable on the outside of the table. Conditional means it looks at one variable over another. So what is the probability of a student being born in Tennessee? Is that conditional or marginal? What is the probability of a student? Great job, Caden. Yes, it is. Great work. More points in the chat. If you look over here, born in Tennessee is over here. And then being born in Tennessee, yes. So the answer is going to be 574 over 923. And I prefer to actually, I did it wrong. I prefer to highlight the full margin of the contingency table, a bivariate display of categorical data. And then the ones that are born in Tennessee are right there. So 574 over 923. There we go. And there we go. This is, we did Marvel Superheroes Fly last time, so 115 out of 794. There it is. I think we allow this answer. I'm gonna see if it works. And then what percent were neutral? We did this one also, so we'll try one more version here. What percent were neutral is another marginal display. Is it making more sense? I think we accept the different decimal answers, so I'm just trying that out. Do put it in the format it asks, but as you can see, we do accept different formats. Be careful if you get it wrong because of that, let me know, but better to put it in the format it asks for. Let's do another version of this right here. Preview. When comparing histograms, this was Blakely was asking, they should have the same horizontal and vertical scale. Yes, they should have the same horizontal scale. And what we mean by this is you go to things like uniform scaling, and uniform scaling is going to make it so if your histograms have different scales on the bottom here, if you click uniform scaling, then they get the same scale on the bottom. Let me unclick it, re-click it, and now we should have uniform scaling. Look at it, everything goes from 0 to 200. So histograms should have uniform scales. Uniform means the same scales. And yes, horizontal axis, that's what we're talking about. That is very, very true. That's a fact. Outliers in a box plot are 1.5 IQRs below Q1 and 1.5 IQRs above Q3. It's just where outliers are. We might see, we saw a box plot. Do I still have the picture of that? No, I don't. But you can see my box plots over here. And that is an outlier right there. This is the highest point that is not an outlier. The upper whisker is the highest point that's not an outlier. It's just there's no data right here. There's a gap. So there is a tiny whisker coming out. And then there's no data from that point up to this point. So the length of the whisker means there's data contained in here. And the whisker can go as high as 1.5 IQRs above Q3 or as low as 1.5 IQRs below Q1. and then IQR is the length of the box. A lot more about this next class. It's a big portion of next class. 4% were neutral about the chocolate they tasted. We've done this one a few times. Neutral is 229, and that's it. And what is the probability of a student born in Tennessee being an honor student? So born in Tennessee, we'll show this one again, but I think this about does it. Any other last questions? We're finishing up office hours here. Kylie and everyone, did you get some hundreds today? Once again, I hope that if you come to office hours or watch this in the future, you get hundreds and get some assignments completed. We did homework 3, we did data analytics 2, and so check those out if you haven't. These are recorded and time-stamped. There's the answer. There's the answer right there. We'll hit save on this so I don't forget. Sometimes I forget, then I got to redo it. I think that's kind of got it. If you have questions, let me know. We're finishing up. Wait, one answered question. Oh, what was this? This was 0.87. You're welcome, Samantha. Everyone getting some points here. Kill time. Our time here. Get it done. Get 100. Did I mess it up? I'll put some answers in by guessing a little bit. We got 100. You're welcome. Get those hundreds. Practice, practice, practice. Once again, do the data analytics early. Do everything early. Because then if you know if you have a problem, you just swing by office hours. And if you don't have time, just drop it and say, hey, Brian, can you do this? And I'll do it later. Like, I'll put it in my list of notes. And then you'll get to see it later. And thank you to everyone who swings by and talks, because that makes this a lot more fun. And you get points. You already got almost half a point on your grade right there. Great work. So if you do this right here, you will get points on your test. You will, not your test, even your final grade. Just talking. You have to talk once every 15 minutes for MoveBot to remember you. That's why I ask a lot of questions. You're welcome. Yeah, well, it's Monday. I'll be having office hours from 1 to 3 in person today. Swing by Stokely Management Center, 2nd floor. With that, we'll do one of our big outros. Bye for now, everyone. Bye.
Hey Brian, what's up?
Hey Adam.
Oh, what's this?
Adam, what are you doing? Adam!
No!